Scattering of X-ray. Scattering of X-rays by matter can be classified into two types. 1. Thomson scattering or coherent scattering. 2. Compton scattering or incoherent scattering. In Thomson scattering, the incident X-rays and the scattered X-rays have the same wavelength. So this scattering is called coherent scattering. Due to scattering, there is only a change in the direction. Compton scattering. According to Planck, the radiation is emitted in packets of energy called quanta. Planck thought that once the photons are emitted, they spread out in the form of waves. But Einstein boldly asserted that the photons maintain their particle nature during their propagation also. Einstein also argued that the scattering of a photon by an electron is called the Compton effect. The Compton effect represents one of the most conclusive evidences of the particle properties of electromagnetic radiation. Compton effect, the experiment. In 1923, Arthur Holly Compton, 1892 to 1962, discovered that when a homogeneous beam of X-rays of sharply defined frequency nu were incident on a light element like carbon or aluminium, the X-rays suffered a charge of frequency of This change of wavelength is due to the loss of energy of the incident X-rays due to elastic interaction and is called Compton effect. The lines corresponding to the longer wavelength in the scattered beam are called Compton lines. Compton effect can be explained Consider a photon incident on a free electron at rest. The incident photon has an energy h nu and mass h nu by c square. The momentum of the incident photon is equal to mass into velocity is equal to h nu by c square into c is equal to h nu by c. Let m0 The electron is scattered with a velocity v along a direction making an angle theta with the direction of the primary photon. The photon gets scattered along a direction making an angle phi with the initial direction of the incident photon with a smaller energy h nu prime, hence nu prime is less than the During the collision, the total energy and momentum is conserved. The total energy before collision is equal to total energy after collision. H nu plus m0 c square is equal to h nu prime plus mc. By applying the principle of conservation of linear momentum, total momentum before collision is equal to total momentum after collision. H nu by c is equal to h nu prime by c cos phi plus mv cos theta. For the x component, equation 2, 0 is equal to h nu prime by c sin phi minus mv sin theta. For the y component, the using the above four equations, we can find an expression for the change in wavelength delta lambda of the photon. Delta lambda is equal to lambda prime minus lambda is equal to h upon m0c into 1 minus cos phi. Equation 5, where lambda is the wavelength of the incident photon and lambda prime discussion of the results. The change in wavelength lambda prime minus lambda is equal to h upon m0c into 1 minus cos phi. The wavelength lambda prime of the scattered photon is greater than the wavelength lambda of the incident photon. Lambda prime is equal to lambda plus h upon m0c into 1 minus cos phi. The increase in wavelength depends only on the angle of scattering phi 1. When phi is equal to 0, the change in wavelength delta lambda is equal to 0. This gives the unmodified line. 2. When phi is equal 3. When phi is equal to 180 degree, the change in wavelength is maximum. Delta lambda is equal to h upon m0c into 1 minus cos 100. The scattering angle and the angle of recoil are related by the equation cos theta is equal to 1 plus h upon lambda m0c into tan phi upon 2. Equation 6. This equation tells us that the photon can get scattered in all directions, but the electron can get recoiled only in the onward direction at angles less than. Conclusion. From the Compton scattering, we get a convincing evidence of the particle nature of the electromagnetic radiation. Also, Compton effect provides example. Find the change in wavelength of an X-ray photon when it is scattered through an angle of 90 degree by a free electron. Solution. Change in wavelength is equal to delta lambda is equal to h upon m0c into 1 minus cos phi. For phi is equal to 90 degree. Delta lambda is equal to 6.625 into 10 raised to the power minus 34 upon 9.